Hey everyone, today I'm going to show you how to use Einblick to build data science workflows. Einblick takes the traditional Jupyter notebook and puts it into a cloud-based canvas where you can build out nonlinear workflows and then collaborate in real time with your colleagues. We've also added many generative AI features helping you to build entire data science workflows with a single English prompt. To get started, I'm going to connect to my dataset, which is on a Snowflake database. This dataset is a promotional offer, and we see that there's some customer demographic information, a column indicating incentive, and then a column indicating whether they accepted the offer. The first thing I'm going to do is pull this dataset out into a table, which allows me to interact with the results. And if I pull out a column, I can immediately see the visualization of the accepted column. I see about 39% of people accepted my offer. And when I pull out the incentive column, I see that there's probably something wrong with some parts of my data because immediately I see that 99% are below 1,000 and a small number are all the way out here. At this point, I would probably go into a Python cell and use the describe function to see what is in my data set. And you'll notice that I've built out a nonlinear workflow where I have a couple objects next to each other as I do this exploration. I see here that the max age is 7,000, the credit score is up here at 84,000, and in general, I notice that there's some outliers across my numeric columns. So the first thing I'm going to do is remove some of these outliers. To do that, I'm simply going to put in the prompt, remove outliers from numeric columns that are more than 3 standard deviations. Didn't write a full sentence, but prompt is able to understand that. It gives me the plan back, and it generates the code for me to remove these values. I see here that this has updated, and now when I rerun this table and then rerun this chart, I see that the incentive column has outliers removed, but I should also see that acceptance has not changed. At this point, I want to understand the correlation with my acceptance variable of all the other columns. But if I simply go ahead and say df.core, I'm actually going to run into an error here because I have some text columns. So before I go ahead and do that, I'm going to ask prompt again to help me out. I'm actually going to ask, show me all correlations with accepted, but one hot encode columns if necessary. I'm going to rely on the AI assistant's knowledge of my data set to actually go and figure out whether or not it needs to one hot encode a column, and then go ahead and make a Plotly bar chart with the correlations after. I see that it's gone ahead, one hot encoded my variable, created the correlation matrix, and now it is installing Plotly, and now I get back a result. I see that the top correlated factor is actually incentive with a positive correlation of 43%, and then secondarily, I have a positive correlation with age. At this point, I can ask prompt to sort these columns to make this more easily to read. Sort bars by correlation. So now prompt is able to go back, check my code, check the context, and execute this prompt. And now I see that age, credit score, then some of the educational binaries are the top drivers. Next, I can build a prototype model quickly and just see what the top predictive drivers are. To do this, Imblick has a number of helper packages. I can now make a quick prototype model where I can use the Imblick's EasyML package to train a machine learning model, and then we're going to go and explore the top drivers once I have this predictive model. And even if I'm not going to deploy this into production, it's a nice way to see which factors work together to predict the acceptance. What we did was combine some pre-processing steps in sklearn with Teapot, which is a AutoML trainer. And this is a 3-step process to build your model. And we wait for about a minute or two while it searches for the best possible model. We see the result comes back and we get an accuracy of 88%, which looks pretty good. Now I want to see what the top drivers actually are. And so I actually can run this ml.explain step, We bring in the Shapley values, and we see that once again, incentive and age are the top drivers. But once we've taken those into account, we get remaining length and least length as drivers instead of credit score. This differs a little bit from the correlation that we have over here, which we can pan over to, and we can compare these two together. At this point, what I want to do is annotate this a little bit and then bring my colleague in. I might go ahead and label this section correlation, and then put a zone around it. Data zones are organizational objects that let me color in a space, label it with correlation, change the color, and all objects within the space move together. You can see that I could easily pull this forward or backwards. As finally, I'm going to add a bookmark so I can share the specific location with my colleague. And then I'm going to go and do the same thing for the prediction model. Now I'm going to invite my colleague to join me. Now that my colleague has joined me on the canvas, we're able to talk and discuss together live in this canvas together. She could also join asynchronously from me and explore and leave her annotation separately as well.